One more clarification about the definition of theta notation. Even though we write T of n is equal to theta of f of n, as in, you know, saying for example that T of n is equal to theta of n square, we need to understand that the right hand side here, which is theta of f of n or theta of n square in this particular example, these actually denote a set of functions. So theta of f of n is actually a set of functions. Informally speaking, theta of f of n is the set of all functions that have the same rate of growth as f of n. For example, when we talk about theta of n square, ignore this section for a moment here. Let's just focus on an example first so that you understand what this really means. When we talk about theta of n square, we are really talking about a set of functions where the functions in this set are functions like n square minus 1, n square plus 1, n square sum plus some generic constant, half of n square minus 3n, 98 n square plus n log n, a n square plus bn plus c for some constants a, b, and c, where a is greater than 0. We can talk about functions like this huge constant in front of n square plus 10 to the power 50n plus this huge constant again. It's actually a special case of a n square plus bn plus c, but you can see that you can come up with literally an infinite number of functions that grow at the rate of n square, and all these functions are part of this set theta of n square. So theta of n square is really a set of functions, and in general theta of f of n is a set of functions. It's the set of all functions having the same rate of growth as f of n. So if we write this more formally, we can write theta of f of n as the set of functions of the form t of n such that there exist positive constants c1 and c2 such that t of n can be sandwiched between constant multiples of f of n. That is, t of n is greater than or equal to c1 f of n and less than or equal to c2 f of n beyond a threshold value n naught. That is, when n is large enough to grow beyond this threshold value n naught. You can recognize this as the definition of the theta notation we gave earlier. But really, uh, this is just another way to define that notation, where we also make it clear that we are talking about sets of functions when we talk about the theta notation. So earlier we defined theta. Earlier we defined what this means when we say that t of n is theta of f of n. What we really mean is that there exist positive constants c1 and c2 such that t of n can be sandwiched between those constant multiples of f of n beyond a certain point. We are basically using that same definition here, but just expressing it in a different way while making it clear that we are talking about sets of functions when we talk about theta of a function. The theta of a function is, strictly speaking, the set of all functions t of n such that t of n can be sandwiched between constant multiples of f of n. And we went through this example. Theta of n square is the set of functions of the form n square minus 1, etc., where all these functions grow at the same rate as n square. And so for every function in this set, you can identify a pair of constants c1 and c2 such that the functions in this set, or any particular function in this set, can be sandwiched between those constant multiples of n squared. So when we say that a function like half n square minus 3n is theta of n square, this is the example we saw a few videos ago. What this really means is that the function t of n given as half of n square minus 3n belongs to this set of functions theta of n square. So this equality operator here really connotes set membership. It's not strictly speaking an equality operator in the literal sense. It's connoting set membership. In a similar way, when we said earlier in an example that 6n cubed is not theta of n square, what we really mean by that is 6n cubed does not belong to this set of functions theta of n square. So we can pronounce uh, these two these two expressions as half of n square minus 3n is theta of n square or belongs to the set theta of n square, and 6n cubed is not theta of n square or it does not belong to the set theta of n square. So it's important to keep in mind that even though we are using the equality operator in talking about uh, in calling some function t of n as theta of f of n, we really mean set membership when we use that operator, because theta of a function is really a set of functions